Hey, it's Jordan with the Young Turks, TYT Politics. I am here with Dr. Ben Kurtman. You are an atmospheric scientist at the University of Miami. I wanted to talk to you. Obviously, we're seeing the images going on right now in Houston, Texas. Now it's going into Louisiana, and it might even go into Arkansas. It was supposed to, Hurricane Harvey, then it was a tropical storm. I think that the corporate media in general does a good job of covering the real-time events, you know, the stunning images and, you know, rescue efforts. There's not a lot of talk about climate change for reasons I'm sure we could discuss another time.
Sure.
For the layman who might understand climate change but doesn't understand how it's making this particular storm and storms like it go from maybe, you know, flooding and damages to deadly. Can you kind of talk about how climate change is making this storm worse?
Sure. So, I mean, the important thing, you know, certainly one important thing to remember is we can't blame any particular storm on climate change. But the question really is how does climate change contribute to this particular storm? And the way to think about it is the Gulf of Mexico since the 1950s has warmed up considerably. And so that's a warmer ocean surface. And that ocean surface temperature through evaporation is the energy that drives hurricanes. And that's a very nonlinear effect. And so a small change in ocean surface temperature leads to a very large change in evaporation of moisture. And so small changes associated with climate change can lead to large changes in evaporation, which is really the fuel that drives hurricanes. So what that can do is intensify the strongest hurricanes due to that increase in Gulf of Mexico temperatures. Mm-hmm. Now, this particular storm, you know, the reason it's so damaging is because it's been so stationary. And so it's just been raining constantly in one place. Not much climate change signal in that, but there probably is a climate change signal in the fuel that supplies the hurricane. And also, you know, our atmosphere is warmer, so that means it's moister, can hold more water vapor, but that also means when we have storms, they tend to rain out more water.
And you were mentioning the surface temperature of the water. Isn't the actual air temperature being warmer too? Those two things mixing.
Absolutely. So that's right. So you can have the ocean surface is warmer, which allows for more larger evaporation, but the atmosphere can hold more moisture because it's warmer. And therefore, when the storm fully develops, it has more fuel, so it can be a stronger storm. But also, it's going to dump more rainfall because there's just more water in the atmosphere to wring out.
Right. And I was reading earlier, most of the times with these kinds of storms, when they're about to make landfall, that is not the period where they're speeding up. But with this one, it did. Can you kind of explain that?
Yeah, that's right. So this storm, in terms of its intensity, amplified very late in the game. That's unusual. Usually we see the storms amplified further out into the ocean, and then the storm will amplify very rapidly, intensify, reach sort of its peak amplitude, and then decay as it comes into landfall. This storm amplified very close to the coast right as it was coming into landfall. That's fairly unusual.
And when you're looking at, obviously, the Paris Climate Change Accords, most experts said it didn't go far enough, but a lot of this has to do with warming and warming temperatures and warming surface temperature on the ocean. So if we don't do something about lowering the temperature, there's different standards. Some people think over 1 degree Celsius. Some people think more. Are we in for more of this at even greater lengths?
Well, the way I think about it is, if you think about Harvey as sort of maybe 25 years ago, there was a 1 in 100 chance of having a storm like Harvey. And maybe today there's a 1 in 50 or a 1 in 30 year chance of having a Harvey. 20 years from today, it could be a 1 in 10 chance of having a storm like Harvey. And all those kinds of scenarios are these multipliers of what's the probability of having a storm like Harvey get smaller and smaller. The chances, you get larger and larger. You get larger and larger chance of having a storm like that. And so, 50 years from now, if we don't do anything about the warming of the planet, we might have a Harvey-like storm every year.
Right. And, I mean, it's a little bit different, but you look at levees failing now in Houston. Part of that's just we don't spend any money on infrastructure, and part of that is these cities were built that weren't built expecting these kinds of storms. That's
right. Well, most of the infrastructure, in the past has assumed a stationary climate. That the rainfall that we had the past 30 years would look like the rainfall for the next 30 years. That's certainly true where I am in Miami. When we think about sea level rise, all of our infrastructure to deal with flooding here was all based on the notion that sea level wouldn't rise at all. And so I'm sure the same kind of thinking went on in terms of the infrastructure in Houston. It was assuming that the climate is stationary, things aren't changing, and the amount of rainfall we've had in the last 30 years is going to tell us what's going to happen in the next 30 years. And that's been going on for 60, 70 years. And we know that's not true. The climate is changing. The amount of rainfall is changing. The temperatures are changing. And all of these things, sea levels rising, all of these things are really challenging our infrastructure.
Now, I want to ask you, I mean, obviously you don't have to give your political views, but I see in the coverage terms like stunning and unprecedented and historic. And kind of like, to me, it seems like, who would have thought this would happen? And, it kind of emotes like this is very out of the ordinary, but it doesn't seem to be out of the ordinary. We're seeing storms like this, whether it's Sandy and other smaller storms all the time. Do you think in terms of coverage, the way we speak about it, the media is missing something?
Well, I think in some respects, maybe they are, in the sense that it's really important to remember that what we're seeing is more extreme events, and we've started to we saw that with Sandy, we saw that before Sandy, and we're seeing that extending again with Harvey and other storms. We're seeing you see that with droughts and floods that aren't tropical storm related. The extreme events that we see seem to be getting more extreme, and that's something that I think I would like to have a more coverage of, more discussion. And how are we going to adapt to an environment where we're starting to see more extreme? So one part of the science with hurricanes is we expect that the bigger storms, the stronger storms, are going to be a bit stronger in a changing climate. We need to start thinking about that. What does that mean in terms of our infrastructure along our coastlines? Mm-hmm. Droughts are going to be more persistent and more intense. What are we going to do about that? Tornado outbreaks. All of these things are likely to become more intense, these extreme events. And that's really important. And we're not thinking about that. And
lastly, we talked about the surface water temperature and the air. What are the factors that are going into the storm creation in itself? Meaning, maybe 10 to 20 years ago, the winds weren't as strong, the motion wasn't as strong, but these storms seem to be picking up at a much greater speed.
Well, I think in terms of the climate change part of that, that perceived acceleration, that is really coming from the ocean surface, and that the ocean surface is warmer, and that's basically priming the pump more, whatever cliche or analogy you want to put in there, but you have a warmer atmosphere, more fuel, and that basically makes that heat engine that's a hurricane more efficient, and that therefore stronger.
And one more, you're in Miami, so obviously,
right.
I mean, if you read 3 stories on climate change in Miami, one says it's going to be underwater in 100 years, the next says could be 15 years,
Right.
What is the state of Miami right now? What do you think needs to be done pretty quickly?
If it looks like we're going to see another foot of sea level rise by 2035, 2040, that's going to seriously challenge our infrastructure. We need to start making robust adaptation strategies. We need to think about particularly parts of South Florida that we're going to return to its natural environment. We need to think in terms of what development we're going to do in terms of locating, new buildings and adapting to different kinds of transportation, more public transportation, and honestly, we're going to have to allow for water to flow more naturally the way it used to, and we're going to have to do those things. And those are really hard decisions that require, buy-in from the entire population. And we need to start thinking about those things now. Even though it's 25, 30 years away, you got to start that process right away in order to adapt. So I'm confident because, the city of Miami Beach is being aggressive. We have new cabinet positions in the city and in the county that are really looking at resiliency. We have processes where we think about resilient redesign of certain components of the city that face the flooding. So South Florida is trying to do stuff. We just want to make sure that there's nothing that's getting in the way for that innovation to go forward, that there's nothing happening at the federal level or the state level that stops these local governments from being effective in responding to the pressures of sea level rise.
Great. Thank you very much, Dr. Ben Kurtman, atmospheric scientist at University of Miami. I appreciate it.
My pleasure.
Have a good one.